That is loud. Holy shit, that's loud.
Today's video is sponsored by Native Sons Goods, makers of the highest quality woven guitar, bag, and camera straps you'll ever see. Native Sons straps are handmade one at a time in the USA with unparalleled love and care. Click the link in the description to check out their new expanded lineup featuring all new 3-inch guitar straps. And remember, when you support my sponsor, you support this channel, and I sure appreciate it. Hello everybody, Brad the Guitologist here. Welcome to part 2 of this 1971 Marshall Super Lead. If you have not yet seen part 1, I suggest you go through that one first. I will leave a link in the description. When we left off last time, I was speaking to the customer on the phone and was going to see whether or not he wanted to go the full 9 yards on this thing or whether he just wanted to do a quick fix. Happily, he did decide to go ahead and do the full 9 yards on this, so we're going to join our program already in progress, and let's go ahead and get into it. Okay, so we have 5 of the 6 capacitors installed. I've also got the pilot light installed, and I have the new switch installed, so we're getting down to the nitty-gritty here. I almost have it done. I didn't want to bore you to tears with showing you the whole thing. I mean, basically we're just installing some components, but this one is kind of difficult to reach because it's directly underneath the board. So what I've done is pulled it out of here, and the way you do this, of course, you loosen this clamp and it will let go of the can, and I'm hoping there's enough lead here that I can solder in the new can and then just get it back down in there without having to pull the whole board, because that would just be a big pain in the ass. So we'll at least film this part. This might be somewhat interesting. Okay, so there we go. I was able to do that. So that's going to save me a lot of time. I'm really happy about that. Now all we have to do is get it back in there. Should be simple enough. Okay, so there's that. It's the last one. So all of these are now in. There's that one and those 5 down there. So that's a lot of can capacitors for one amplifier. Took a little while. Probably took about close to a couple of hours. I've watched almost the entire movie Rob Roy while I've been doing this. So. Okay, so here we go. We've got everything ready. We've got all of the caps replaced. Everything's ready to go. I'm just going to dial it up on the variac. We're going to measure the plate voltage as we go. We're also going to measure the plate current with our 2 probes here. And we'll start dialing up on the variac. I'm going to start off pretty slowly here. And we can see what the voltage at the plate is right there. And right now it's at 50 volts. I'm going to try to turn that where you can actually see it. Okay. And we can also monitor these 2 down here, and that's going to give us a plate current reading for this tube and also this tube. So we can monitor a couple at a time here. Okay, we're at about the halfway point here. I've got 0.36 amps overall, 22 watts of power. I'm not reading anything yet on the plate current. There we go. Now we're getting something. Now they're starting to conduct. You can see them going up here. 2.0 over there. I've got 4.5 over there and climbing. It is somewhat interesting that we're this far off. I've got a reading of 6.1 right here, and over here I have a reading of 10. One thing I have not changed yet, I have not changed the little capacitors up here that are on the board, so I haven't changed that capacitor, and also I have not changed these other two here further down the line. Not that concerned with them at the moment. I just want to make sure that mainly that the bias and everything is going to be okay here. But like I said, it's looking right now like we've got bias on these tubes that's off from one side to the other. I kind of doubt it's because of mismatched tubes. These are matched, so, and they're brand new matched tubes. So I don't think it's that. I think what it probably is a difference in value on the screen resistor. So we've got, you know, one screen resistor there, and we've got a totally different type there that we're measuring for that tube. So it could be that because of that, it's throwing off the plate current. We're a little bit closer now. We have 16 on one of these, and on the other we have 22. Still a pretty good ways off. They're not as close as I would hope. And now we have 20 and 28. Measuring 398 plate voltage on this one tube. And if I check it over here, it's 398 also. And this is just what we want to do. We kind of want to dial this up slowly and give these brand new capacitors kind of a chance to form up for the first time. But you can see here, like I said, we got about 22 or so over here, and then over here we have around 29. That's the plate current. Okay, I'm going to go ahead and dial it up the rest of the way here up to 120 volts. We're about 1.5 amps, 144 watts of total consumption. Over here I have 44 milliamps, and over here I have 33 milliamps. Okay, so over here we have 0.0448 amps, and we're going to multiply that by 495 volts, and that's going to give us about 22 watts of plate dissipation. If we look at this one over here, this one has 0.034, and we'll multiply that by 495, and that gives us 16.8 over here on this tube. But if we look at our RCA receiving tube manual, and if we look at EL34s, about 25 watts is the max plate dissipation that we want to try to achieve. We're at 22 on this one over here, but we want to try to get that down to around 70%. Okay, that would be 25 times 0.7. So that's about 17.5. So over here we're way too high, and over here we're about spot on. So we have a bit of a problem. But if it comes down to it, I'll measure the screen resistors, and we'll see if that's what's causing it. I mean, there are other things that could cause it as well. It could, you know, it could be something along the lines of bad ground connection on the cathode. It could be you know, bad socket. And I'll come in here and I'll measure these screen resistors, and I'll see if maybe, you know, maybe it's just that we have a couple of screen resistors that are way off on this side. Okay, so measuring the oddball one right there, that black one, it is measuring bang on 1.03K. We'll try this one right beside it. Pretty much bang on as well at 0.990. Maybe these are drifted. Nope, 0.98. And then the next one down is going to be 0.98 on that one as well. So yeah, those are not the problem, the screen resistors. So let's take a look at the 1959 super lead here on the output, and if we look at the bias feed right here, we will see that the bias comes in here with this diode through this 15K up to here, and it goes through two 220K resistors, just like it does on Fenders. I think it's those two right there, and they are 220Ks. So I'm going to measure each one of those and see which one of those has drifted. Okay, so the first one on that side is measuring 222 And this next one is measuring, that one's also at 222. So it's definitely not that. We're going to come from over here where that orange wire is. That orange wire runs up under the board. And all right, it comes over here and feeds the grids. Let's see. That one's 5.6, so that's right on the dot. This one, 5.6, right on the dot. This one is 5.6, almost right on the dot. This one, 5.6, right on the dot. So it was a good idea to check those, but those are not the issue. Okay, so it's at this point after performing these last couple of operations that I went ahead and decided to give this thing a test. Unfortunately, during the test, the amp started red plating on one side only. That means 2 of the tubes began red plating. The other 2 remained fine. And I began to think that maybe this was due to the output transformer perhaps being imbalanced from one side to the other, but that's a really rare problem to see. So what I decided to do was kind of go back to first principles and look at what I'd already done and look at what I might have missed. I went ahead and checked these 5.6K resistors. They were all okay. Those are the grid stoppers into each of those tubes. Also checked all of these 1K screen resistors, and they're all okay. Checked these, what was this, 220s, I believe, that are basically, you know, in the bias circuit, and they were all okay. So really about the only thing left is one of these these 0.022 capacitors, and so it's leaking DC voltage and putting positive DC voltage on the grids of these tubes, and that would explain, for one, why they were biasing incorrectly, and that would also explain why they would go into red plating like they just did. Okay, here we are back in this thing, and the two that I'm focusing in on are these 2 right here, and one of these is bad. I'm not sure which one goes to which, but let's see. We've got green and orange wire, and if we look over here, which one is the green and which one is the orange? Okay, looks like orange is coming over here to this pair, and that pair is not the one we need, so it would be the green one. So this cap right here I'm looking squarely at as being probably bad, but I'm probably going to replace both of these. It's probably not necessary, but if one has gone bad, then the other one can't be that far behind. Reason would, you know, dictate. So and also, I mean, you've got a couple more of this type as well, so if it does turn out that these are kind of leaky, I'm going to go ahead and pull one leg at least and test them and see if they're leaky at all. And if that is the case, then I'm going to go ahead and replace both of these, and I may go ahead and replace those 2 as well. Okay, so that was a bit odd. I tested those capacitors, and they seem to be fine on the equipment that I have. Now, my equipment that I test capacitors with does not test them at higher voltages, so you know, I can't really do that test without the amp on. So went to fire the amp back up, plugged it into the variac, and now I've got nothing whenever I turn the thing on. So I'm thinking we probably blew a fuse at the point when I turned the amp off or something. It spiked and took the fuse out. Yep, look at that. It took the 4 amp mains fuse. So that's a bit scary that it took the mains 4 amp fuse. Okay. Now, but that's why you have fuses, man, so that you know, something blows and you're protected. Okay, so new 4 amp fuse. I'm going to start this thing low once again. You know, I don't think this is a case of something being shorted. It's not, you know, the fuse was simply taken out because we have an excess current draw somewhere. That one set of tubes is clearly being over biased, and we have to figure out why. Okay, right there we have negative 25.8 volts. Right here, negative 23.7 volts. 23.5. 23.4. It looks like it's going down. It's gonna, maybe it'll even keep going down, I don't know. Yep, there's 4. It started out at like 23.7 or something like that. And if that continues to go down and doesn't stabilize, then, you know, we know we've got a runaway situation with that particular capacitor when you get it up to actual working voltage of the amp. I'm going to dial it up. That's why it's going up right now. I'm going to dial it up a bit, and we'll see if it begins to fail. And here on this side, of course, we have the negative 33.3 volts. On the other side, we're more negative at 38 volts. So clearly one side is going more negative than the other side. Now why that is, I'm not 100% sure. But it very well could be a leaky capacitor. It could be that capacitor right there is leaky, and it's turning this point right here more positive than it needs to be. Of course, we have the bias voltage coming in right here on the other side of these two resistors, and it comes in. This is your negative supply, passes through this resistor, and it also simultaneously passes through this resistor, and then this one goes to one pair of tubes, and this one goes to the other pair of tubes. Right now, I mean, we're at 36 on this one side, and we'll check this other side as well. And it seemed to, okay, see there how it's just running away? It has really crashed. Negative 14, and it probably is red plating right now. It may even be on those output tubes. But we're going to shut it down before that happens, because there's really no need to, you know, let it keep climbing and climbing. We know what the problem is. Most likely, we'll replace this one first and see what it does. Good. Okay, yeah, so now what I want to do is fire it up again, and I want to check again the voltage at this point, and I want to see if it continues to dive like that. And if it does, obviously we have a different problem. On this side is still more negative for sure, so something, you know, something's still unbalanced. Something happened there. Did you see that? It skipped down to 25. What the hell was that about? Okay, so that's not solving the condition. I'm not necessarily concerned, but I'm a little bit, it does pique my interest that, you know, that grid resistor right there has been changed at some point, and that one right there is still original, and it matches these two over here. Now I've already determined that those resistors are fine though, so I don't think it's them at all. It's just interesting to me that one of them has been changed. So okay, so what I want to do now is pull the power tubes, and I've already done that, and I want to check and see if with the power tubes out, if we still lose bias voltage right there at that point. If it's not tube related somehow or tube socket related, then we should find a point where it just stops, you know, stops moving and just pretty much stays rock solid, and then the other side should be pretty much the same. I want to check the other side of this capacitor too. Okay, on the other side of the capacitor right now, with 104 volts on the input, there's 210 volts on the other side of that capacitor. 225 volts on the other side of the other capacitor. We have 42.3 volts negative right there. 42.3 volts negative right there. So the problem only occurs whenever we have the tubes installed. So they are identical whenever the tubes are not installed. So what I want to do is reverse the tubes now. So I want to take the pair of tubes that was formerly on the side that ran away, and I want to swap them over to this side. I want to swap the other ones over to this side. That's going to tell me whether it's the tubes or whether it's something to do with the socket. If it stays with the socket, then we've got an issue, either a conductive socket, or we're not getting a good ground on one of the cathodes over here, or something of that nature. But we're gonna isolate it. We'll figure it out. Let's swap the tubes around first. Okay, so I've swapped the tubes around. Now the pair of tubes that formerly red plated when I tried to test it have been swapped over to this side, and the ones that were fine are swapped over to this side. And we'll see if this side still dives even though it has the different tubes in it. I don't look for it to follow the tubes because they're brand new tubes. I have no reason to believe they're going to be bad or anything like that. So I'm definitely staring straight at these sockets or the leads that are running to it. You know, we've got this green wire that's running up under the board. You can't really see where it goes, and it's possible that maybe that's getting up against something. Maybe it's getting hot. Maybe it has just a tiny sliver of insulator that's off of it somewhere along the line, and it's bleeding off to ground, or you never know. It could also be a socket. It could be a faulty socket. So let's fire it up again. Okay, we're testing. All right, this is the side that was doing okay. That's at 41. That's really okay. 41.7 on that side too. But this is really before the tubes have gotten a chance to start conducting. We'll see what happens when that begins to occur. Okay, we're getting noise at the output now, and we should see this start to drop if my hunch is correct. I mean, we should see it drop anyway, but no. Holy crap. The problem has followed the tubes. Look at that. The problem has followed the tubes. That is pretty amazing. I would not have guessed that. So that's at 38. And this one has dived all the way down to 24 now. So how about that? I wonder if okay, so I'm gonna tap on the tubes, the pair that's been red plating. I'm just gonna tap on the tubes themselves. Sometimes tubes have like a loose element or something inside that's kind of shorting, and sometimes you can tap them and kind of loosen those two elements from each other, and you'll never have that problem again with that tube. But right now it's definitely the tubes. I think that's the first time I've ever gotten a set of those matched tubes from Antique Electronics Supply. First time I've ever gotten any that were bad on arrival. And they're bad on arrival. Alright, well that's a disappointment. One of these two tubes, I'm guessing it's, I don't know, probably not both of them, but one of those two for sure is faulty. On one side, it's just it's causing the bias to dive, and it's probably one of the internal parts of one of the tubes is whenever it heats up, it is slowly shorting against one of the other parts, and that's causing the failure. Gonna need some more tubes. I think what I might do is put his old power tubes back in this thing just for now, and just test it out. Okay, so there are his old tubes reinstalled, and these are I mean, these are probably pretty good tubes when they were first made, but I mean, they just look like they've been pretty well worn out. They're Siemens labeled tubes, and like I said, they were probably pretty damn good tubes when they were new. Now they look baked, but which is the whole reason why I suggested we change them in the first place, because they look like they had a lot of hours on them, and they're from the early 90s. So let me check this again. Let's fire it back up, and again we're going to start out with it about 103 volts on the input, and we'll just see how it goes. Okay, here's the side that we changed, and we can see it's at 40.5, and we'll probably drop a little bit. The other side, 41.2. It's a little off, but not too far off. You would expect a quad of tubes to be somewhat off from side to side after this many years, because they are going to wear unevenly. But they aren't that far off, and it's not diving yet. hovering around 40 right there. This other side's hovering around 41, so far so good. Yeah, the difference between a couple of volts from one side to the other is not an enormous deal. I mean, that's workable. You can't have it just drop completely off. And I don't know, man. It's looking like it's dropping on this side again. I'm starting to feel some shades of the Mesa Boogie. No! I don't even want to say the word Mesa Boogie, because, you know, not good. It can't be! We'll see where it goes and if it stops here. You know, I just find it irrational that swapping the tubes around, you know, that other set of tubes would get to follow the tubes, and now, no, it's diving off. There it goes. Holy crap. Well, that made some noise. Well, that was super interesting. The bottom fell out of the bias until it reached the cutoff, and then, you know, we lost sound at the output. But I also heard like the tube itself kind of crackle. You see we're still dropping 34-ish here. And then over here, you see the wattage right there going up, 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 and the current is going up, 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 up. Okay, we're down to 30. I expect, there it goes. Now, what do we see back here? Anything? I wonder if I might have a bad tube socket. Yeah, I'll tell you what. I mean, these tubes, the tube sockets rather, I mean, they just look a bit crusty. They don't, you know, they look like somebody has maybe soldered around on those a few times. To me, maybe that's not the case, but it does look to me like they have seen a soldering iron or two in their day. So I think what I might do is reflow all the solder joints on the socket, do the same thing on this one over here, because I mean this side does seem to be the culprit somehow, because this is the side I'm testing, and it's definitely diving off without a doubt. So I need to go back to plan A and further narrow this down and see why that's happening. Okay, so I'm basically just going to start over here at the where the bias comes into feed over here, and I'm just going to work my way down to the tube socket and do both these tube sockets. I'm just going to flow all of the solder. I mean, this has been done at this point. I'll do it again though. Maybe add a little bit here. I'm just going to reflow the solder at all of these points first, and then we'll see where that gets us. But I'm not looking for this to solve it, but I do want to ease my own mind that, you know, I've done what I could here. Yeah, at this point I'm just about half tempted to replace all four of these output tube sockets, really, because they're just not looking so hot. All this crud that's on here, and they just I don't know, man. They just look old and baked too. And tube sockets can go bad. They can go conductive. Tube sockets will just get to the point where you can't get a good connection on the pins. I may as well go ahead and clean those again and make sure that's not the case here. And I think I'll go ahead and do that before we go any further with it, because that would definitely cause a problem. Like if you're not getting a good connection, say on you know, I don't know, if your cathode pin or something on one side, on one of the tubes, started losing connection when the amp heats up, or if the, you know, if the screen starts losing connection as the amp heats up, anything like that, it would definitely throw things off. All right, I want to clean the sockets, the tube sockets. I want to also retension the tube socket pins. Okay, so I'll pull these tubes one more time. Okay, now the sockets. See what we can do about those. Okay, for cleaning sockets, I have found these things to be pretty useful. These are interdental brushes. Okay. Yeah, there's two little contactors, one over here and one over here, and they basically spread out. It's actually part of the same, it's all one piece, but they will actually spread out. So what I want to do here is try to get down in there and I'm going to try to push these together if I can. So like this one right here, I want to try to hold it on one side. Look. And just gently push them towards each other, because, you know, over time these will spread apart and they'll kind of lose their springiness, I guess. Okay, well, I've scrubbed the hell out of those sockets, and I also got down in there and retensioned every single one of those. And I mean, if it's gonna work, it'll be now, because that's about the best I can do with those. And if this doesn't work, I'm probably gonna move toward replacing all the output tube sockets. But it looks like something has definitely been spilled on this thing. Somebody had a beer sitting on top of it or something at a gig, and it spilled and came down inside of the amp, or Coca-Cola or something, because it all got down inside of the tube sockets as well. You could actually see it. There was crust on the walls inside of the tube socket, just like this brown crud. And it would come off with this little interdental brush, but also scrape some of it off, almost like you would at the dentist's with this screwdriver. Kind of scraped it all off, and also retensioned those contacts. So hopefully that will take care of it. One more thing I forgot to do that I meant to do here is clean the pots, and I'm going to try to use a different pot cleaner here. This one is a Max Pro electronics lubricant. I was recommended this by a viewer to the channel, and I went out and got some of this stuff. Actually, you can get I bought it on Amazon. You can get it on Amazon. I'll put a link down in the description if you want to try this stuff out. But you get a hell of a lot more for your money. This bottle is 11 ounces, whereas if you buy Deoxit, like Fader Cleaner, which is kind of the same sort of thing, you can see the difference in size of the bottle there. This one is 2 ounces. And they are, I forget what the prices are, but I think this is about 15 bucks for 2 ounces, and this is like, I think this is actually cheaper than that for 11 ounces. So anyway, if this works well, then I'm probably going to go with this in the future, just because Deoxit is so damn expensive. You can see it kind of came out a little bit much there. I expected it to act like the Deoxit. The Deoxit actually has a stopper where it'll only allow you to spray a certain amount every time you pull the trigger. This one you have to kind of be careful with it. Okay, before I finish this thing up, a couple things. First of all, this indicator light that they sent me is the wrong one. I don't know if I ordered the wrong one or if they sent me the wrong one, but anyway, it is wrong. It's supposed to be a 6-volt light wired on the 6-volt winding, but they sent me the 120-volt version of the Marshall light. But that's okay. I'm actually going to wire this onto the power switch instead, so that'll take care of that. No big deal. It's not, I mean, it's not like a huge mod or anything. I just have to clip the wire, go into the 6-volt, move it over to the 120, and move this one over here to the switch. On the power cord also, you'll notice the neutral wire coming in here. It's going to the fuse, through the fuse, follow the yellow wire down here, and the yellow wire is going to the switch. So all that stuff is on the wrong side of the transformer, so I'm going to swap the hot and the neutral wires around so that that's correct. All right, well, here we go. Let's try this again. Same thing. I'm just going to put about 100 volts on it. Is that on the shot? There we go. Okay. Well, it's holding steady so far on this one side. I mean, better than it was a while ago. Okay, it's 41.6 on one side. 41.6 on the other side. That's actually the best it has been this whole time. Okay, this is where our drama gets a little complicated, and I debated on how best to present what happened in the video in the interest of brevity. So the bias remains solid after my socket cleaning and retensioning with the old Siemens tubes, so I reinstalled the new Electro-Harmonics power tubes. Those also remained stable on the bias for a long period of time, and the imbalance between the pairs was gone, but only so long as I was not introducing a signal into the amplifier. As soon as I tried to play a guitar through the amp, the bias on one side again immediately crashed, and it was at this point I decided it was time for those old output tube sockets to go. They were either too oxidized, too dirty, or fatigued on the connection terminals to maintain a connection with the tube pins, or at least that's what I thought must be the case. So this thing, yeah, it did run away again. I did not expect that because I did thoroughly clean and tension all of these sockets. I do still believe it is a socket issue, and it's just a matter of they're not going to come any cleaner than I can get them without actually extracting the tube sockets and like soaking them in some in a solution to try to clean them internally. I don't think there's going to be a way to clean those with my standard methods. So they're just going to need to be replaced. Now, just to show you what I mean here, here are the tubes out of the sockets, and I think actually maybe one or two of these sockets had been replaced before. Either that or they were using some kind of different sockets at the time, and they just had like a bucket full of them, and that's possible too. They were just kind of grabbing, the first one that they got their hands on, and you can tell here this one doesn't have really any markings on the top, but that one does have some markings. Not exactly sure what it says, but CPH and then a number. And then we've got one there that matches that one. And then this one over here is a completely different one altogether. So we've got three different styles of socket here. And you could see that, even though I did my best to clean these and really got down in there with that brush, I mean, it's still dirty down in there. And like I said, I think unless I were to actually pull each one of these sockets out and like soak them in a solution to try to clean them, we're really best just to replace the sockets at that point. I wouldn't call these the greatest sockets in the world anyway. I mean, they're ceramic sockets and they're decent, but obviously they're not getting good connection as is. So I wouldn't have great confidence in trying to clean them. So okay, I'm not going to bore you with this entire process of replacing all four of these, but I will let you stick around for one of them. And I think what I'm going to do is just clip the old leads. It'll be the fastest way of doing this. And then I'll just clip and restrip, with the exception probably of that resistor. And I'll leave this one on, I think, until I get it out. And I might reuse these, but I might also replace them. Okay, now I need to strip these wires. I also need to prepare my new socket, so I won't bore you with that. Resistors, I have gone ahead and decided I want to replace those. The old ones The other one just looks a bit tired. I mean, it's got a little crack in the ceramic there, which is not a big deal. I mean, that's just in the outer ceramic. But since I'm going to have a real nice fresh looking socket anyway, I don't see the point in pulling that old thing off of there. Okay, one last look inside this thing before we hopefully wrap it up for the last time. Just to recap what all was done. We replaced the power switch, replaced the indicator light, we replaced one of the fuses, we replaced all 4 output sockets along with the screen resistors, and I think that at the end of the day looks a heck of a lot better. Definitely a lot cleaner. We replaced those 2 capacitors right there. We also replaced all of the can capacitors, of course, and there were 6 of them in this thing. There's 4 of them there, 1 there, and then the other one which is underneath the board down this way. So that's it, and also we replaced all the tubes. So that's it. Let's plug this thing in and give her a test. Okay guys, it's been a little while actually since I've messed with this thing, and a lot has happened in the meantime. First I had to order tubes, and the first tube set that I ordered was a set of electro harmonics that were matched by Apex Matching. Those are Russian tubes, and usually Russian tubes hold up pretty well, you know, for the price, and they're pretty reasonable for what they are. And so I, advised the customer to go with those, but it turned out one of those tubes had a problem. It was either that or we had a problem with one of these sockets that caused a problem with one of the tubes, and I don't know which came first, the chicken or the egg, but I did send those tubes back and got a refund on those, and instead bought this quad of JJ's. But anyway, it could have been a case that we had two problems simultaneously, but the end result was one of those tubes was just, it would actually come up and you could bias the quad, and it would bias fine on both sides, but then when you went to hit a note on your guitar or you put any kind of input signal through, it would start diving on one side, the bias. So as soon as the tube was asked to conduct at all, that's when it kind of started running away. So that, long story short, sent those tubes back and got a quad of JJ's in here, and what we're going to do now is go ahead and bias these JJ's with these all new output tube sockets, and yeah, I think that's going to solve the problem. That is loud. Holy shit, that's loud. Good Lord. God, that's loud. Alright guys, I think you kind of get the idea here. This thing is extremely loud, extremely in your face. Before I piss off my entire neighborhood and everybody in my family, I want to go ahead and shut it down right there. So yeah, thank you guys for joining me in this long journey to service this 1971 Marshall Super Lead. Please hit subscribe down below, hit the bell to receive all notifications, and we'll see y'all later.